Hey, Mr. Wellman, this is Jonas. I'm reporting on the final project, the analysis of rocket launch data. My partner for this was Daniel. Here is the movie we digitized using Logger Pro. Here we have the y velocity versus time graph, the position versus time graph, and kinetic energy, gravitational potential energy, and mechanical energy. Here we are seeing that the kinetic energy rises as time goes on, but then falls back down as the rocket slows down. And we see that the potential energy here continually rises, gets higher and higher and higher, because the higher you go, the more the gravitational potential energy is. And here's the PowerPoint slide that we made that shows the first part, which was the y, Vy, Ay, kinetic energy, potential energy, and mechanical energy versus time graphs. I'm just going to go in order here. So the rocket motor burn time, the Ay during the rocket burn, the Ay immediately after the rocket burn. And what we found was that the rocket motor burn time was about 5.9 seconds. This we just took from the graph, and we just looked at how long it took for the rocket to reach the highest point. How we found the 2.998 meters per second squared was we looked at the velocity versus time graph. We shaded the area and did a line of best fit, and the slope gave us the acceleration, which was 2.998 meters per second squared. The Ay immediately after the rocket burn was 0 meters per second, as there's no acceleration after that point. The next part was asking us to find the apex of the rocket, the flight time, the rocket displacement from 1 second before burnout to 1 second after. The apex was 171.5 meters, and this number we just got from our graph from Logger Pro. The rocket flight time was 5.9 seconds. For the displacement 1 second before burnout and displacement 1 second after burnout, what we did was we looked at our Logger Pro numbers here, and that will show us. So here, 1 second before. 1 second before would give us 9.348 meters. And then to find 1 second after, what you would do is 1 second after, go to 2 seconds, which will give you 31.30 seconds. And you subtract that from 1 second, and that's how we got this number over here. That's how we got 23.1 meters for displacement 1 second after burnout. Okay. And then here is the average velocity from 1 second before burnout to 1 second after. What we did was we shaded from 0 to 2 seconds, 0 to 1 being 1 second before burnout, and 1 to 2 seconds being 1 second after burnout. After we shaded that region, we looked for the slope, which was 12.62, and that's the acceleration. Here's a picture of a drawing that we did for the free body diagram before launch. Before launch, there's a mg pointing down, which is mass times gravity, and then there's also a normal force in the upwards direction, giving it a net force of 0. Here is the free body diagram during the burn. There's mg plus force of motor pointing down, and then there's also the force of rocket pointing up, giving it an overall net force in the upwards direction. Here's a free body diagram just after the motor rocket burn. There's an mg pointing down. There's also the force of rocket pointing up, because at this point, although it's not going as fast, it still has a net force in the upwards direction. At the apex, there's no acceleration and there's a net force of 0 as it temporarily stops at the apex. The free body diagram just before the rocket hits the ground would just be mg, as in this time it's just in free fall. And after it hits the ground, there's mg driving it down to the ground, and then there's also the force of ground on rocket being applied in the opposite direction. Here we have the rocket speed, the maximum rocket speed and the minimum rocket speed. The maximum speed was 49.88 meters per second at 3.4 seconds. The minimum was 3 meters per second at 0.400 seconds. And we got these numbers directly from the Logger Pro data. Next question, is mechanical energy conserved? We said no, mechanical energy is not conserved because the total mechanical energy in a system, the sum of the potential plus kinetic energies, remain constant as long as the only forces acting are conservative. But when we added the potential and the kinetic energy, they were not staying constant. So kinetic energy maximum and kinetic energy minimum. The maximum kinetic energy was about 1,555 joules at about 3.4 seconds, and then the minimum was 0.400 seconds at about 5.64 joules. On the potential energy maximum and minimum, so the maximum was about 2,100 joules at 5.9 seconds, and the minimum was 5.64 at 0.400 seconds. The work done by a rocket motor during the burn, the work done by gravity from launch to apex. There was no work done by rocket motor during the burn because cosine of 90 would be 0. 0 times the force and the distance will still just be 0, so the work done is 0. However, the work done by gravity, which is mgh, was 2,143.8 joules. And that is the end of our project. Okay.